Okay, grade 10s, let's do some more algebra. So let us make it maths. Okay, so we're doing fractions today. And for our fractions, let's just recap these very quickly. And that is, if you're multiplying fractions, you just multiply numerators and denominators. So, if you've got a half times 3/7, then you just 1 times 3 is 3, 2 times 7 is 14, right? Okay, and if you're dividing, you do that tip and times, keep, flip, switch, all of the ideas. So in this case, if you've got a half times, or a half divided by 3/7, then you just say, well, that's the same as half times 7/3, and then multiply across as you did before. And finally, common denominator. So if you've got a half plus 3/7, then we go, common denominator here is 14. If sometimes you just multiply these two numbers, you could have a lower common denominator. And in this case, it's just 14, in which case, well, for the 2, we kind of went, we had to multiply by 7, so we multiplied that by 7. So we had 7 over here because it was 7 times 1. And for this one, we went, multiply by 2, multiply by 2. So plus 6, which in this case would give us 13/14. But that idea of common denominator, I think you've got. And so let's do this with a bit of our beloved algebra. Ready to hit it. Okay, so key thing that I keep asking quite often is how many terms, how many terms, how many terms? So in the numerator, how many terms are there? Well, there are 2 terms. We have a nice strategy of turning multiple terms into one term. What's that strategy? How do we kind of turn multiple terms into one term? Well, factorize was kind of the strategy we tried, and we've just done a whole lot of factorization, right? So we're like, cool, there's a common factor of 3x, that goes in there 2x minus 1 times equals, and then we do that kind of cancelling idea. And what we're doing when we're cancelling, by the way, so I'm going to show this in between step, maybe in a different color. So you're saying, well, this is the same, look, 3x goes in here twice. So this is 3x over 3x times 2x minus 1 over 2. We see if we multiplied denominators, we'd get this. If we multiplied numerators, we'd get the numerator. So in our cancelling, what we're really doing is saying, how can we manipulate this to get something that's 1? Same thing over itself as 1, unless, of course, the denominator is 0. So presumably x isn't 0 here. So we can go, that's just the number, there's our kind of cancel. But what we're really saying is this is the number 1, and 1 times anything is itself. So hence we have 2x minus 1 over 2. And that's what we're doing when we did that kind of cancel idea, going 3x goes in here once, 3x goes in here twice. Look, there's our 2. Okay, so I'm not going to show that every time, but that's mathematically, I guess, what we're doing. Rock on, example 2. Cool. So example 2, we've got 3x squared plus 3x minus 18, 2x minus 4. So again, our strategy is quite similar. Let's factorize, and it looks like we're going to have to do this numerator in 2 goes. So denominator was easy, 2x minus 2. Numerator, common factor 3, x squared plus x minus, not 18, come on, minus 6. 3x looks like a trinomial. And we've just spent all our time on factorization, which is why I'm kind of cruising through to go, our key concept is multiple terms, factorize, simplify. That's the key bit. We've just done lots of factorization. So we've got x, probably a 3 and a 2, 1, hey, plus 3 minus 2. So, and here's a nice little tidbit is, quite often something will cancel. But we kind of half expect it. It'd be boring if we got here and nothing cancelled. So when we saw the x minus 2 in the denominator, it's very unsurprising to see an x minus 2 reveal itself in the numerator. And that's because these examples and questions have been constructed like that. Of course, given a random equation, random expression, That's not always going to be the case, but here we go. So now we merrily do our crossing out, and we understand what we're doing mathematically when we do this cross out, cross out. We're going x minus 2 goes in there once, x minus 2 goes in there once. So therefore, we've got 3x plus 3 over 2. That's all we can do. Okay, if we're multiplying, same deal. Do each bracket first. Each bracket, each fraction at least. So, times, let's throw in a question, x squared minus 1. How can we factorize that? Looks like a difference of 2 squares to me. So, x plus 1, x minus 1. This part, this 15. See, 15 already we're going to kind of think of as 3 times 5. I'm going to leave it as 15, but you see this 3 times 5 idea. Okay, 5x squared minus x. What's our highest common factor there? Well, it's 5x, and rather unsurprisingly, hey look, there's an x minus 1. Okay. You've probably done this cross-cancelling idea before. So I'm going to show the in-between step to see why we can cross-cancel, and then we're going to cross-cancel all we like. So the in-between step is if we're multiplying, we multiply numerators. So we're going x plus 1, x minus 1 times 15. One term on the numerator. Denominator, 3 times 5x, x minus 1. So now we've got one term over one term. So we can play our cancelling game as we played before, our simplifying, because we know what that actually means. So now we go, x minus 1 goes in there once, x minus 1 goes in there once. 3 goes in here once, and 3 goes in here 5 times. And 5 goes in there once, and 5 goes in there once. So in future, what we do is we just skip across, and we go, okay, let's cross-cancel, as we call it. Just say, well, x minus 1 goes in there once, and x minus 1 goes in there once. Because we know that in the next step, that'd be in the denominator. 5 goes in here once, 5 goes in here 3 times, 3 goes in here once, and 3 goes in here once, with that kind of cross-cancelling. So we don't have to rewrite it like this, because we know what we're going to do. Okay, and so we're left with x plus 1, and on our denominator, we're just left with 1. So in which case, we can easily go goodbye. Okay, let's keep rocking on here. And maybe for the sake of the video, and you can come back with questions, is just look at kind of the first few steps and then not tediously go through the whole thing. 2xy minus 2y, x squared minus 4, 3x minus 3, 6x plus 12. To deal with this divide sign, what are we going to do? Well, we're going to tip in times. So we're going to change that to a times, and we're going to tip that one. Okay, cool. Now, I definitely think it's worthwhile doing the factorization in the same step. So we don't do the tip in times and then in the next one factorize. So here we know we're going to factorize, right? This is easy. X plus 2, x minus 2. Here it looks like it's a common factor of 2y, x minus 1. Looking good. And then this 6x plus 12, maybe I'll do this. This over here, remember, is on the numerator up here. So we can factorize out like that. And this bit over here, this 3x minus 3, we're going to factorize out a 3x minus 1. So tip in times, and then go from there. Cross cancel, simplify, blah, 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 all of those things. And because I feel happy that we've perhaps looked a little bit mathematically why we're cancelling and cross-cancelling and those things, I can stop doing the little air quotey things, and now I know when we say that, we have some mathematical reasoning for saying that. Okay, equals, and so it goes. Okay, now we're dividing. Now remember that whole, no, so this divide here, we're dividing by that fraction. So because we've got division and multiplication, we just go left to right. So the first thing we do is this division. So therefore, we're going to have, so let me just show the tip and times just to make it clear. The first thing we're doing is x squared plus x minus 2, but I wouldn't suggest you show all of these steps. Minus 8 over x squared plus 4x. That's because that's the first thing we do. So we're dividing, so then we're doing a tip and times. Now that we've dealt with that division, we can do the next thing, which is the multiplication. So that's going to happen next. So that's why we're only going to tip and times the one part. Kind of just preempting a question of, do we tip and times both of these parts? No, because you're just doing this division first and then the multiplication. Order of operations, bed maths keeps things unambiguous for that. Bed maths behind my head. So means we're good to go. Okay, and from there we just multiply. So factorize, simplify. Whole thing will simplify nicely. Last piece of the puzzle. Pause, breathe. Okay. Last piece of the puzzle is, here we factorize and we got 3x minus 2 over 2 minus x. I always like to put these things in brackets to make sure we got one term over one term. And there's an x minus 2 and a 2 minus x. So what's just dying to jump out and be done here? Our beloved switcheroo, right? So x minus 2. So it'll be very useful if that were x minus 2. But here we had a negative x and a positive 2. And now we got a positive x and a negative 2. So if we put a negative, remember that's like having a negative 1 outside the brackets. So if we've got negative 1, well that's negative x and positive 2. Now things cancel quite nicely. It's quite useful to show that. So therefore we've got 3 divided by negative 1, which is negative 3. It's also why I wanted to put the 1 there, to have this idea of it's not 3 over negative. Like, what's negative? 3 over negative 1. Because what we should be doing is x minus 2 goes in there once as well. X minus 2 goes in there once. Right, that's it. You can always pop in for more questions. Whew, that was quite a few of them, right? We really rocked on. Exercise 13, as you know, friend time. Okay, so that was it. Let us always make it maths.